from a colony and the drone is flying upwind, does that mean they go to different places?
Yeah, absolutely. That's part of the key strategy, that they will meet recipients from other hives. Otherwise, they'll be mating with their brothers, as it were,
So
which we don't
it
want.
counts as, no.
So when the virgin queen finds this drone congregation area, she will fly into it, and the 9 ODA that she's giving off from her mandibular glands, that will attract drones in from about 60 meters away. She'll also open her sting chamber and she'll release pheromone from her Kozyevnikov gland, and that has again an effect of attracting drones in from a closer distance. She also uses pheromone from her turgid glands, and that has the effect of encouraging the drones to catch up with her from about a half a meter away, and then to actually physically mount her and mate with her. It's nothing to do with the physical prowess of the drone, or what he looks like, or even what he smells like, because he is, of course, catching up with her from behind. So she's got no real knowledge of what he's going to look like. But
not even a quick backward glance.
Not even a backward glance. It's all to do with pheromone. And if it wasn't for the pheromone attraction that exists between the two sexes, it would never take place, and that's why it's so important to this part of honeybee life.
It's interesting that you mentioned the Kozyevnikov gland, because that's an attractant in lots of different contexts. So it attracts young workers around to the queen to look after her. It attracts, in the worker bee, it attracts other bees to come and sting in the same place. And in this case, it's you being an attractant to drones. So it's 3 different contexts that the same gland is being used.
Yeah, many pheromones are multifunctional, especially pheromones exhibited by the queen, and it would depend on the age and type of bee that is going to react to it.
So as we said, everything in the hive emits pheromones, and brood is no exception. So open brood, older open brood, will inhibit ovary development in conjunction with queen pheromone. So if you've got a colony that has waiting for a virgin to mate or has lost their queen, you won't get laying workers kick in as long as you've got some brood. The brood will suppress laying workers' ovaries developing, and that's a useful thing to know. So if you're, the virgin's got a window of 5 weeks or so to mate, and if you're on like 4.5 weeks and you're thinking, actually mated or not, you could stick some open brood in there, which would perform 2 functions. Number one, if they haven't got a queen, they would use young larvae to make queen cells, or the open brood would also stop laying workers kick in. And we all know when you get laying workers, it's kind of game over.
Mm-hmm. Is that what you refer to as a test comb?
Yes, a test comb.
Mm-hmm.
There are other effects of brood pheromone. So as a releaser, the releaser effects are the brood itself will give out signals to the nurse bees telling it what kind of food it needs. So larvae isn't fed a universal food. When it's a young larvae, it will get a different formula to when it's an older larvae. Drone larvae will get fed a different formula than worker brood. And as we know, queen larvae will get fed royal jelly all its life. So it's very important that this food is finely tuned depending on what the larvae is going to develop into. When the cell's ready to be capped over on the 5th day, we know that the larvae will then give a pheromone to say, I'm ready now, cap me over. Unfortunately, in this country, you don't have the pleasure of varroa yet. The varroa mite can recognize this pheromonal signal at day 5 and slip into the cell just before it's capped over. And in this case, the pheromone is called a caromone because it's signaling to an animal, a different species. Also, brood pheromone will stimulate pollen collection because obviously pollen is a big component of larval food. So that's a bit of an obvious one. As we've discussed earlier, it can inhibit worker ovary development. It stimulates the hypopharyngeal gland, so that's a physiological effect on the bees. It increases royal jelly production, again, that's a physiological effect. And it can delay foraging and inhibit juvenile hormone. And so basically, if there's lots of larvae that need feeding, the nurse bees will be stopped from going through their sequence of jobs to become foragers, because they're needed for brood rearing. Then let Martin take the next one, because this is quite an interesting one.
Okay, so what we've got here is a test to see how hygienic bees can be in their behavior. And what's happened is this area of brood that you see in front of you has been killed, either by freezing with liquid nitrogen or by pin pricking in order to kill the larvae beneath. But what they're trying to do is to find out how the bees respond to this dead larvae. And so what happens is when it dies, the larvae give off a pheromone. There's still pheromones even after death. And they use two pheromones, beta-ocimene and oleic acid. And they work synergistically with each other. One encourages the bees to come and examine the cell and to uncap it, and the other one encourages the bees to actually remove the dead larvae or dead pupa that they find underneath it. So neither will work without the other. And the interesting thing is that all bees seem to show levels of hygienic behavior, but it's the threshold at which they start to actually carry out this behavior. So some bees are much more receptive to the pheromone and will come and start cleaning out larvae very readily. Others need much higher levels in order to stimulate the behavior to take place. And this is one of the things we've been looking at, certainly in our country, because it has repercussions for whether they can detect and remove pupa or larvae that have been infected with varroa. So it's certainly one of the things that the Western world is looking at.
Yeah, I'm very skeptical, because I think if we cherry pick characteristics or behaviors, even if they're good behaviors for bees, you're going to possibly lose other important behaviors. You know, we're not clever enough. We can genetically modify them a little bit, but we're not clever enough to make it sustainable or balance it out properly. And Marla Spivak, who did the work in America, the Minnesotan hygienic bee, did find that in her journey to get hygienic bees, there was an inbreeding part where actually they were clearing out healthy larvae as well. So things can go awry very quickly if we mess around genetically with bees. I think it can become unbalanced very quickly. Anyway, that's just me. This is 2-heptanone. This is a release of pheromone.
Yeah, this is the one that's released by the worker bees on guard duty at the front, and it's released from their mandibular glands. This is the exact opposite of the low volatility queen pheromone. This is highly volatile, and it will waft around in front of the hive, and it will encourage other guard bees to come and join in the defense of the colony should they come under attack from either other bees or wasps, as we call them in this country, hornets, whatever.
Yeah. This one we've already discussed a little bit. This is isopentyl acetate. So if a bee stings you, she'll leave a little bit of this chemical there, which will attract other bees to come and sting you. It's a volatile chemical. It will evaporate off quite quickly. And if you do get stung, if you wash or blow a bit of smoke at it, you can mask the pheromone. That's why we no longer use lead gloves. And some of these are very nice. And you'd get sting glove, and that pheromone seemed to stay in the leather of the glove for longer than necessary. And so eventually the glove will be covered in stings. And so anytime you put your gloves anywhere near the hives, you are wafting this isopentyl acetate, and the bees were just fed up before you even started. So we chucked those away. We now use light nitrile gloves, which we can wash, or sometimes bare hands even. We found out it's easier to work gently with the bees, and we get stung less. This is another interesting one. This is a primer pheromone. It's ethyl oleate. I'm going to let Martin take this one.
Okay, so ethyl oleate, what actually happens is that the forager bees that are returning need to be, with nectar, they need to be unloaded by the house bees. And if they're not unloaded quickly enough, then that starts to induce a behaviour in them that they're not going to go back out.
Why wouldn't they unload it quickly?
If they've already got sufficient food in the...
Well, there's nowhere to put it.
Or, yeah, they've got sufficient, or that they can't stash it anywhere. And so these foragers don't end up carrying this information that would be necessary. And so what seems to happen is there is a very sort of micro level of fermentation, and this chemical is created in the body of the bee, and this then, when it gets passed across to the house bee, this actually suppresses the behavior to go out and forage again, or to encourage other foragers to go out and actually work.
So it regulates. If there's no, it stops the nurse bees from becoming foragers because they're not really needed to be foragers.
That's right. Yeah, yeah. If there's nothing, if there's no more foraging that can be done, then it will prevent that behaviour from working through.
So it's a beautiful feedback system.
Yeah.
This is the one that most beekeepers are familiar with. This is not pheromone. So you see bees on the entrance or around the evidence. Yeah, now they're finding this pheromone. It's a cohesive pheromone attracting. And you don't want to be on it. We go home. But it's on the now we can't it's not. So it's lemon verbena. And I actually had a perfume which I bought. It was supposed to be calming, to calm you down perfume. It's based on essential oils. And I read the ingredients, and it was all of those chemicals. And I thought, oh my God, I'm putting Nasinol pheromone on myself. But also you find things like my sister was cleaning her bathroom with a citrusy cleaning spray, and her bathroom filled up with honeybees. And I think what happened was there must have been a swarm passing by, and she had her bathroom window open, and she was using the citrusy smell, and some of them got confused and just peeled off into her bath. It's also used during swarming to get the swarm to settle, usually on its initial thing, or even when the scout bees have found a new home, and they'll nazzing off bees in. So it's an attractant, and it's used quite a lot.
I've heard they also use it to scent flowers, floral saucers.
How does that work?
So when they actually take nectar from a flower, what they do is they will scent mark it with a bit of Nasinov, and that seems to be a cue to other bees not to bother to try and visit that flower because they've already sucked it dry, as it were. The Nasinov doesn't last too long, and that usually should be sufficient time for the flower to refill its nectaries and then be more appealing to a bee. So it's a short-term thing.
Yeah, you see bees hover around a flower, and then they kind of sniff, and then they decide not to visit it and go to the one next door. So that's neat, isn't it?
Interestingly, solitary bees, semi-social bees, they do a similar sort of thing, but they use mandibular pheromone rather than Nasinov. And so all these bees have the same sort of glands and use the same sort of chemicals, but they use them in different ways.
Yeah. Even empty comb doesn't produce pheromones, but it will retain pheromones because wax is absorbent. It's an organic substance. It will absorb chemicals, substances, and smells. It will retain those cells. So empty comb actually stimulates the hoarding instinct in bees. So bees have got a hoarding instinct, and if they've got empty comb, they will feel compelled to fill it up. And we all know there are such things as swarm lures, aren't there, which is based on Nasinov pheromone. But to be honest, I've never found them work. But if you put a bait hive, I usually put it on my shed roof, and you put some empty comb in, particularly comb that had brood in, you'll get a swarm easy peasy.
Yeah, I always refer to it as old dark cheesy comb.
Yeah, it's much more efficient than I think. I mean, the synthetic swarm lures, I've never really known one to work. But this, and some people I've read in old books that they used to rub lemon balm around the inside of the hive, but a bit of cheesy old, that works every time. So we're going to summarise now. The communication achieved by pheromones depends entirely on context. So it depends on the age of the bee, her physiological condition, her age, her individual character, even her genetic inheritance and nutritional state. All of these things will affect if the chemical being emitted is going to elicit any kind of behaviour or not. So, for example, old foragers are not attracted to the queen. In fact, they're almost repelled by her. And this is why the queen tries to get young bees around her, because they're going to do her less harm. Old bees will actually attack a queen, even their own queen sometimes.
We did have an incident last year. We were asked to go and look at some bees for one of our friends when he was away on holiday, and we had to drive a fair way to get to it. And when we got there, it was a bit dull and a bit drizzly, not really bee weather.
All the bees were at home. It was very crowded.
All those old foragers were in the hive, and when we opened the hive, we found the queen, and they were really they were harassing her. She was nervous.
I think what happened was the queen was nervous, and she overproduced pheromones, and the older bees were just going for her, and Martin had the presence of mind to puff a bit of smoke at her, and they dispersed. But I think if we hadn't done anything, they would have bored her.
Yeah, and you do get that when you mark queens or clip queens. I must admit, we don't clip queens here, but I know it's still very
We
popular.
don't really mark queens mid-season, do we?
No, again, because the balance of the bees isn't right in there. But I remember in my early a master beekeeper to mark a queen, and he did it very professionally and very well, put her back in the hive, and all the bees just jumped on her, pounced on her, and bored her and killed her. And he was distraught, and we all laughed, to be honest. But
Horrible. I would have cried. The strength of the signal, particularly volatile signals, may depend on the conditions inside and outside hives, so how crowded the hive is, maybe even the atmospheric pressure, the ventilation in the hive, other conflicting scents which may interfere or confuse signals. So in this country, for varroa control, there is a treatment which is based on thyme, which is a very strong smelling treatment. It stinks, and the bees don't like it very much. And in the past, when I've used thymol for varroa control, you find that the colony is just not functioning as normal. They don't feed. I think it interferes with supersedure. The guarding behaviour at the entrance is not very coordinated. So I'm really wary of putting strong cells in or around the hive.
yeah, we tend to use that thymal treatment, still the most popular treatment in the country, but it actually is used normally around about the end of July, early August, right when you might be having supersedure going on, or indeed when you want those bees to be guarding for robbing.
So also, conditions outside the hive could affect the bees, especially things with mating and orientation, alarm pheromones or food gathering, maybe affected by environmental circumstances, or other conflicting smells outside. If you've ever cut grass around a beehive, the bees don't like it very much, do they? They come and attack you. Apparently, cut grass gives off green leaf volatiles, which has got similar components as alarm pheromones, isopentyl acetate, like an acetated smell, which the grass gives off to help protect itself. So it will attract insects then to come and attack you, stop you attacking the grass. It's a sort of, I think that's called an anemone. When we're getting towards the end now, I can see the time's ticking on. So beekeeping applications, obviously queen rearing is an obvious one. You know, if you take a queen out of the colony, they will start making queen cells. Or if you separate the queen from brood rearing area, they will again make queen cells through the supersedient. So we've learned how to do that to help us make new queens or to encourage bees to make queens. We've mentioned a test comb, which you can use to check for queenlessness. And it's the same purpose. If you're using a queen in a cage to a colony, you can put smells in which would confuse the bees so that they're less likely to attack her. So
yeah, you can mask it with smoke, with heavy smoking, or even perhaps I've seen it done with air freshener. That will work. Normally, when you're putting two colonies together, we can slow down the time that it takes for the bees to get together, and that allows the pheromones and the colony odor to somewhat mingle together. And you do that just by uniting over some newspaper.
And swarm attraction, which you can use a bait hive, or like I say, I think old comb is more effective than the swarm lure. So pheromone communication is a finely tuned and complex dialogue between all members of the honeybee colony. It's got many layers of possibility. It's got many layers of possibility, and there are feedback loops which ensure that the resulting behaviour of bees is flexible, and that is key. The honeybee colony needs to be plastic and flexible and opportunistic with so many backup systems so that they can survive. And the superorganism has got all this complex behaviour in order to get their genes into the next generation. It's all about survival. And there are so many plan B, plan C, plan D. Can go wrong, and very often as beekeepers, we kind of don't respect that. So I think we need to be more aware that the bees are communicating all of the time, and we shouldn't go in with our big, thick beekeeping gloves and expect them to comply.
Yeah, we're using our senses, we're using our sight and our touch, but we're not very good at using our sense of smell to detect pheromones, what's going on in the hive.
So if you've got any further questions, you can email us directly, cdensley@buckfast.org.uk or mhan@buckfast.org, and we will do our best to respond to any queries that you might have. It's taken us 2 days to do these 2 half-hour things. We've been so rubbish, so many blips and takeouts, but finally I think we've got here.
Well, I hope you enjoyed it anyway. We certainly had a lot of fun putting it together, and as I say, I hope it reaches you okay with the technology available. And yeah, thanks very much for asking us to do it. And if you want another talk in the future, then get Kevin to have a chat with us.
Bye-bye, Kevin.
Yeah, bye.
Hi everyone, my name is Elizabeth Frost. I work as the technical specialist for honeybees within the New South Wales Department of Primary Industries. Thank you so much for joining us today on the 41st annual Tocal Beekeepers Field Day, longest running beekeeping field day in Australia. It's a brave new world and we're happy to have you with us in it. So today I'll be presenting to you on the topic of long live the queen. In our case, it may only be 1, 2, or 3 years life for a queen honeybee. And we'll be talking about some facts, some myths, some stats, as in statistics, and some ideas about the future of recording information about your queen bee. So the photos we're looking at now, on the left-hand side, you've got adult queen bee. She's got a red marked thorax, which the beekeeper has marked so that she's easier to find down the track, and so that they know exactly what age she is and some information on her origins. You see there's worker attendants surrounding her, attending to her needs, so feeding, grooming, and making sure she's on her merry way, laying eggs throughout the colony brood nest. On the right, we've got our Long Live the Queen title popping out of a queen cell. So that's a cocoon that the queen develops in from the larval stage, undergoing complete metamorphosis to the adult bee stage. To start with a bit of statistics, in New South Wales, the state of New South Wales, there are 367,280 registered hives, and that means there's just as many queen bees registered in New South Wales. So she's the engine room, essentially, of our hive, each one of our hives. And she produces all the individuals within the hive, which, through collective effort, create honey, harvest propolis or plant resins, pollen for their protein, amino acids, fatty acids, mineral and vitamin needs, and a number of other tasks. There's a few myths out there, and popular media loves to spread them about honeybees. So as we continue on our learning journey about our beehives and our bees, we learn that some things aren't always correct. So in this Justice League of America comic book, we've got the Queen of the Universe saying all the Justice League are the drones of the queen bee. So in this case, the drones aren't doing anybody's bidding, but their own in terms of spreading their genes throughout the environment through mating with virgin queens. So the reality is we've got three castes within the hive: the worker on the left, the drone in the middle, the only male in the hive, and the queen bee on the right. So typically we have one queen bee in the colony. There's situations where there may be two, say there's swarming behavior kicking in, or the queen's getting old, and so she lays some eggs in queen cell cups, and her worker progeny or daughters raise replacement queens for her. The drones are seasonal. However, Australia has such a long and mild production season in some areas, most areas, in fact, that some drones will overwinter through the winter months. So who is this queen really? She's the mother of all the bees in the hive, tens of thousands of workers during the height of the season, a few thousands of drones potentially, given the seasonal condition and the age of the queen. And she's the only fully developed reproductive female in the colony. So she and the workers are both from fertilized eggs. However, it's solely the larval diet that determines whether this female larvae will develop into a worker bee or into a queen bee. And they both have really specialized organs that develop through these different development pathways. So whereas the queen bee, obviously she's fully reproductive, laying all the eggs in the colony, whereas a worker has specialized organs for foraging, for wax production, for stinging, in the case of the workers with a barbed sting, whereas the queen has a smooth sting and can sting multiple times. Back to the queen though, she also influences colony behavior. So some people think the queen controls everything, but it's a really, a relationship in harmony, ideally, when the queen is producing these chemical odors. So they have their different languages in the hive. The queen has a chemical odor language through production of pheromones, which indicate to the worker progeny that she's alive, she's well, she's present in the colony and productive in the colony. And workers, in turn, through grooming the bee, or the queen bee, they spread this pheromone throughout the colony, indicating to their sisters that she's alive, well, and present in the colony. So she may live 1 to 3 seasons, and that depends a lot on how much, she's allowed to lay, how much work the colony goes through in the season. Does it stay in one static location? Does it get moved around? Whether it's moved around or in a static location really has a lot to do with the nutrition available at both sites. So in both instances, we may have situations where we need to decide, is this site still suitable for my hive? Does it have enough nutrition to access itself? Do I need to supplemental feed or move it to greener pastures per se? That is, areas with more prolific flowering events. Queen facts, she can lay her own weight in eggs in a single day. So she can be a prolific egg layer. And she's busiest laying spring through autumn in Australia. We've got, again, a very long season compared to where the strains of bees that we typically like to keep in Australia originate. So Europe, through Western Europe, and the bees' original range is through Western Asia, Middle East, and Africa as well. So within the hive, some people say she's got it pretty good. She's groomed, she's fed, they even remove her feces out of the hive, but really she's got an incredibly important job to do. So those workers want her within the hive and producing eggs to maintain that hive production and all the different jobs that go on in the hive. Hive hygiene, undertaking of dead or diseased bees, wax production and comb construction, and obviously honey production and pollen ripening into bee bread. I'd be remiss not to mention the boys. So the drones, you can see in the top image, we've got two drones from two different colonies, one Italian type and one Carniolan Caucasian black type of drone. So they're really a critical component in queen quality. She may mate up to with 28 drones, recent studies have shown out of Sydney Uni, and the average drones that she mates with is 12 on her mating flight. So timing is everything for the queen breeder. You have to, once queen cells are ripe, put them out, you know, rain, hail, or shine, because queen emergence waits for no one. Queen is, and this organism in general, is really fascinating from its reproductive strategy that's evolved over time. So this is a system called haplodiploidy. So that is where the queen lays fertilized eggs to produce females or unfertilized eggs to produce males, the drones. And more down to the basic field skills, how do we find her? She's the most important individual in the hive in most instances, and there's a few key steps for success. So if you're wearing specs, make sure you bring them. Pick a nice day. So don't pick one that's got high wind or chance of rain where bees are going to be not too happy to see you. You want to treat the colony as nice as possible. So gentle movements, not banging boxes or lids around, using nice cool smoke, not hot smoke. You want to keep the bees calm while you're looking for the queen so that it's easier to observe her walking as you normally would across the combs. So in this photo, my colleague Madeline Kratz is holding up the frame, and she's got the sun coming over her shoulder so that it's you know, at a nice angle also to see eggs in the bottom of the cell. So if we see eggs, we can be quite sure that there is a queen in the colony that day, or at least the 2 days prior, because an egg is an egg for 3 days from laying. So I like to hold up the frame with the sun over my shoulder, and I'm scanning the frame, looking across for that key shape for a queen bee. And when in doubt, you've looked at all the frames on both sides, don't be afraid to look at the inside of the box or above the queen's cooler. You might have a little bit of a bend between the tines that she's just squeezed through in her efforts to expand her brood nest. Record keeping is a key thing that we do within the National Honeybee Genetic Improvement Program. So with all livestock species, there are different traits that you can select for, maintain, and maybe even increase, such as honey production, temperament, and certain disease traits. So with the queen breeding program, we'll be collecting as much data as we can that's valuable in increasing or at least maintaining certain traits such as honey production and different brood nest traits and health traits, as well as pollination traits. So we've got some Better Bees WA members on the top right, and we've got a recorder beekeeper in North Dakota on the top left, just to indicate the tools you might choose to record in the field. So when we're taking our data, we want to make sure we know the queens are those breeders that we've put in. So I'll just switch the screen to a few queen videos here so that we can have a look at the benefits for marking queens and maybe strategies for how to look for queens. So with this video, we've got Better Bees WA queen, Western Australia's longest running, and actually Australia's longest running breeding program. So this Italian queen is marked with yellow. She's going about her business looking and measuring cells in the colony to see which one is clean enough and suitable for her to lay a fertilized worker egg in. And you can see the workers are following her around. They're antenating, so they're checking her out with their antennae, which are scent detection organs. And she's going along her merry way to look for where to lay eggs. You get a little bit more of an active or potentially agitated queen. It might be trickier to find her. So in this case, we've also got a marked queen, and sometimes they really hightail it away from you and away from the sun. So this one, you'll see shortly, she's trying her best to get out of the sun and move to the other side of the frame. So she is what we might consider a runner, but if you have a keen eye and you're kind of scanning that frame, you should be able to catch her abdomen because it's much different looking than the workers, whether she's a golden Italian queen or a redhead cordovan or a black carniolan or a Caucasian bee. And our last example, once you've got your eye in, you can look at a frame and you can think, okay, well, I won't get distracted by this patch of adorable honey slurping worker bees, and I can see, dang, there's the queen, she's got the green dot. I've seen her, I know she's active and still present in the colony, and I'll go about collecting the data that I've set out to collect. So back to the apiary site where we're collecting this data, we want all of our breeders in the one apiary site, so we know that there's a control here. So we know they're all foraging within that 2 kilometer or more radius. We know the species mix, the rainfall of the area from historic weather data, and that they're all kind of under the same conditions for testing. So this data sheet is a bit of a catch-all one. We wouldn't expect most beekeepers to collect all this information, but it's just a suggestion to start getting you thinking about what are the traits in my colonies? What can I measure? What would be a good thing to measure in addition to my, twice annual mandatory pest and disease check in my hives? If you want more information about that data sheet and other outputs from the queen breeding program, you're most welcome to look at our website on AgriFeatures. We've got a team made of Department of Primary Industries, Sydney Uni, University of New England, the Animal Genetics and Breeding Unit there, Better Bees WA, non-for-profit Wheen Bee Foundation, and our manager AgriFeatures for this federal government funded grant. And we're also partnering with horticulture industries and beekeeping industries, which you see below. You can follow us as well. We've got social media pages through Extension Oz Professional Beekeepers, and you can find us on Twitter, LinkedIn, and Facebook. So please get in touch, and thank you so much for listening. Just remember, queen bees need healthy trees too, so she needs good nutrition to support all that egg laying and egg production. So think about the landscape in your areas. Could it use more native trees, and how could you be a better advocate for native nectar producing flora? Thanks so much for listening.
Next up we have Kevin Tracy, Traineeship Development Officer Honeybees, talking about making cell builders for queen rearing operations.
This is one of several methods. This one that I'm doing is referred to as the cloak method, C-L-O-A-K-E method. And the way that works is you set up a queen right colony, that is, the colony has a queen in it. You make the colony not have the queen by manipulating the boxes and brood. So that equipment again that you need beforehand is sugar syrup, a feeder, internal feeder that will go into your box where you'll put your syrup, white sugar only in use, and a cloak board of some kind. You have one that slides and you can leave it on permanently or take it off each time, is entirely up to you. But the purpose for this is to prevent queen pheromones coming from the box with the queen in it into the box where you're going to be placing your cells, where you put your graft. All things that you need, as well as a closed container of some kind that will hold frames, because we're juggling frames throughout this exercise. You may and probably will need some replacement frames. If you use foundation, is good. And the other thing that you need is your prepared cell bar. This is one I prepared earlier, and one that you will need to have your cell cups ready, because it's advisable to place this in the day that you set up your cell builder. So now to set up your cloak method cell builder. Firstly, a light puff of smoke just to settle bees. This one is set up and has a honey super on top of a double brood box, which is my preferred way for initial setup, like early in the season. Later on, I will leave a queen excluder under the second box. Okay, so now we open, obviously. Put what we can out of the way. And now a critical factor that you must consider and be aware of is finding your queen. That's very important at this stage, because in case you do not know, if there is a queen where you put cells, your cells will not take. You won't get any queens out of that graft. No queen there. And of course, it's always a thing with a double brood box. You have a lot more frames you need to go through to look for a queen. While you're going through looking for the queen, what you want are some food frames, that is with honey, and preferably honey and pollen on them, or nectar and pollen as a food source. They do need a lot of space and a lot of energy to do this job. This is an example of a honey and pollen frame that I do want to use. I'll just give the little shake so you can see. I don't know if the camera can get that, but it's got honey on the outside, fresh nectar in that arc, and pollen throughout here, and that's on both sides. This is a good nutritional source for the bees while they're making cells. So I'm going to leave this one in there because this box is going to become the box where I build my cells. Food for the bees, pollen and honey. What I want now is to make room for three frames, 2 of brood. That's 2 frames of brood. You do not want with that brood any aged larvae that can be turned into queens, because they'll start doing that and you may not get as effective a graft. So take out frames that aren't a food source or pollen or the like. If you have in your double brood any brood, you don't want that up here yet. Another thing we need to put in here will be our sugar feeder. You want to get that in early so you know the space that you're working with. This works in 10 frame or 8 frame. This is an 8 frame box, and my feeder is always at the ready. And it goes against the wall. Note, I even have written on here for display purposes, white sugar only at a 1-to-1 mix. I know the queen isn't up here. And so what I want to put in now are my cell cups, my cell hanger. These cells don't have a graft in them. Well, you want to put this in for them to clean up. So this is referred to as a hanger, the cell hanger. The horizontal are cell bars, and the black ones that you can see are referred to as cell cups. That will sit in a placement where you can put a frame of brood on either side of that graft, what is going to become your graft. Now, for the sake of the photographer, I'm going to smoke the bees a little bit more. Okay, so now I put my box to the side again. Really bad handling technique in there. I'm still looking for the queen because I did not find her in that box. It is imperative that you locate your queen. You will not have a successful graft if you do not find the queen. So here we go. Let's find the queen. I like to challenge people. Which frame do you think the queen is on? This one? Yes, I have a nod from the side. No queen. Sorry. But that, for me, is not a bad frame of brood because it's not old, it's not too young that the bees will work on a queen. There's some pollen on it and some ready to hatch bees. The object is to get as many bees as you can, young bees, nurse bees, in the top box, because they're the ones who are going to look after those cells to maturity. You can use a cloak method set up for your cell builder as either a cell starter or a starter and finisher. Another good frame. She's been working pretty hard. That's good. That's what you want. A note for you as well is that in a cell builder, it's quite good to have an older queen because you're kind of working at an emergency stage or a swarming mentality, if I can use that language, for the colony to rapidly work on cell building. So we will be putting a couple of shakes of bees as well as 2 frames of brood with the bees on them. So there's quite a few bees going to go up. I have found the queen, and so you can isolate her any way you like as long as she survives the isolation. And for my purpose, I've taken out the couple of frames that I pretty well want to use, so I'm okay to put her back in. All right? But I won't. And the reason I won't is because I'm still going to shake some bees into my top box. Okay, so she's reasonably safe there. What I need to do now is take my frames of brood that I'm going to use in this upper box, in the cell building box. As you can see, that is a frame with brood pretty well right across. I like to have a frame that is quite full and near to hatching. That just makes the space more cramped, and they want queens so they can fly away and create a new colony. All right, so I'm happy with that frame, and I will place it next to my hanger with all of the bees. Okay, so I need another one like that, which I have here. And this has older larvae in it. They won't make queens out of them, but it's again about pheromones and numbers. And I will put that in on the other side of my hanger. Something that can't be done without mentioning, you must be conscious at all times of biosecurity and the health of your bees, especially from a pests and diseases viewpoint. And nutrition is key to successful grafting. Now, I still have my queen on this frame, but I want as many bees as I dare without taking too many from the bottom box. They still have to survive, but they'll have the queen, so everything will still go well. I'll do a couple of shakes. I can put the queen back in because the bees I'm shaking are on frames that I've kept outside. And put this back together. And soon we're coming to the really tricky parts. The tricky part being that at this point in time, you need to turn your bottom box 180 degrees so that the entrance is facing the opposite way. To this end, when I build boxes, and I would recommend this, I do 2 entrances, one at the front, one at the rear, which means you don't have to turn boxes. Having said that, I'm now going to turn the box. 180 degrees, and if you don't have the boxes fixed, just pick the whole lot up, turn it around. Did somebody say, why do you do that? I'll tell you why. It's because we are going to set up the cloak board on top with the entrance facing the original direction. So now all of the field bees that are not in that colony, the foragers are out, will come back into my cell builder and increase that population further still. So now I can return the cell building part, box above, back on. Any remaining bees on frames, you can see that one hasn't been anything but drawn out. The bees come off. The frames will, when I get the rest of the bees off, go back into a sealed container. The exercise now is, so I shake the bees in, I don't, and then let them settle a little bit and add my sugar syrup. This you will want to have prepared in advance so that you're not pouring it in boiling hot. For instructions on how to make sugar syrup, look at your Tocal College Ag Guide on queen bee rearing. Available now. And I will, on my first day, fill that pretty well to the top. And then I can gauge what kind of intake there is in the couple of days to come. Okay, so remember, it's critical to turn that hive, face the original opening in the opposite direction to what the original was. Your cloak board will receive all of those foragers, and the foragers who leave the bottom box will go out forage, and they're orientated to this position where you will find them. Now, I have another box that has yet to go on. I use a clearer board. For those who aren't familiar, this is either a clearer board or an escape board. It has virtually one-way valve. I put it so that the bees can go from the top box into the box below, which again increases that population. I can then remove that box for the rest of the exercise without any bees, which means I have direct access when I want it to the cell builder. And that, as we can say, is pretty well that. Now, a couple of more words, always more words, try and stop me. A couple of more words. For my operation, I always did this over a period of 3 days. That's 3 days. Setup, as we've just done, is day 1. Day 2 is when I take out my hanger with the cups on it. I check the sugar syrup, top it up. I go and I do my graft. I then bring the hanger back on day 2. It's still on day 2. My graft is day 2, goes in the box. And then day 3, I turn the boxes back around to original configuration. Does that make sense? So what I do then is this box will be gone because I've done the clearer. They're all gone. I leave this box in that orientation, but I remove the cloak board or take the slide out of the cloak board, turning the box to original entrance. Only one entrance back to the original on day 3. So 1 is setup, 2 is graft, 3 is return to original position with a queen excluder. They will finish those cells above a queen-right colony once they're started. And you must ensure that you put a queen excluder in between the brood box and the cell builder, or you will lose your graft. I do hope that makes some sense for you. Watch it again if you need to. Contact us if you need a bit more help with that. But you can raise queens, and this cell builder method, that's the cloak method, is easy to use once you get the hang of it. Thank you for your time. All the best with your queen rearing. It's great. Everyone can do it.
I hope you're ready to get up out of your seats and dance, because up next we have Fiona Chambers from the Wheen Bee Foundation talking about the waggle dance.
Hi, this is Fiona Chambers. I'm the CEO of the Wheen Bee Foundation. And I'm really pleased to be able to share with you today what it is that Wheen Bee Foundation has been doing for Australian bees and beekeepers. And there's actually quite a lot happening. For those of you that don't know who the Wheen Bee Foundation is, we are a registered charity that is dedicated to protecting bees. What we do is we fund research. We raise awareness of the importance of bees for food security and ecosystem health. We connect people together. And in order to be able to fund and deliver all of that, it's really important that we raise funds. So it's another core function of what we do. What we don't do, though, is engage in policy and lobbying type work. So we recognise that that's very much the role of the peak industry body, ARBEC, and we support ARBEC, and we have supported ARBEC in the past with things like funding their strategic plan and with supporting the recruitment of their CEO and those sorts of things. So ARBEC is very important as a peak industry body, but we don't do what ARBEC does. We do different things. So this presentation, really, I was really pleased to have the opportunity to really talk with you about what are all the projects that we've got on at the moment, and there's about 11 of them, and who we're working with, who we're partnering with in those projects. Specifically how you as a beekeeper or beekeeping industry stakeholder can benefit from those projects, and the next steps to getting involved. And I think you'll find when you see these projects that there's something in there for everyone. Not all of them are going to be relevant to all people, but there's something in there for everyone. As a bit of a broad overview, so those 4 key areas that I said that we did: fundraising, research and development, education and awareness, and connecting people. These are all the programs that I'm just going to touch on very briefly in this presentation to let you know where we're working and which projects are focusing in which areas. So to start with, I'm really pleased to be able to launch today our newest project, which is Powerful Pollinators. The Powerful Pollinators project is all about bringing back the buzz. And this particular project is about encouraging insect pollinators in farm and urban landscapes. So we've got a number of partners, and it wasn't possible to be able to fund this project without the support of Burt's Bees and the Australian Government through the National Landcare Program, and also Rotary District 9800. So these are the organisations that have co-funded this with Wheen Bee Foundation and enabled us to partner then with Sustainable Farms Project and Western Sydney University and other organisations too, to be able to present and publish these particular work resources. So what we're launching today is the Powerful Pollinators Planting Guides. They're bioregional planting guides, and the first 4 that we have published are for Western District of Victoria, Mallee, Victoria, South Australia, West Gippsland in Victoria, and the New South Wales Southern Slopes. So these guides, what we've also got under development, we've got more under development with the Blue Mountains, and very soon we'll be publishing the first of 3 urban resources, urban guides, to help people know what to plant in that specific urban bioregional area around Melbourne. So in terms of what's coming next, we're hoping to be able to produce another 10 planting guides across New South Wales. And with a national expansion, we're really planning to be able to have about 20 bioregional guides all across Australia by the end of 2021. And we'll be partnering with local universities and appropriate partners on each of those guides. What the guides look like, they're an 8-page A4 fold out, and right in the middle there's a bloom budget calendar, and there's nothing else like it around the country at the moment. So it's really about helping farmers to understand, looking at what crops they've got, what's their pollination window, and what are the types of Australian native plants that they can plant to supplement and support that pollination window. And what we're trying to achieve is a wider flowering window so that it's really supporting pollinators, not just the honeybees, but other local pollinators too. So our website is now live, so go to the Wheen Bee Foundation website and you'll be able to have a look at that and download for free those guides. So there's 4 there at the moment and more will be coming. One of the other projects that we've been very, very pleased to partner with is the Honeybee Genetic Improvement Program, which I'm sure Liz Frost has spoken about. So that's been a major project for us. It's a $3.7 million project over 3 years, and Wheen Bee Foundation's role has really been about working hard to seek the industry co-investment that was necessary to be able to get that project to happen. So roughly about 42%, about $1.5 million was really directly as a result of the work that we did, door knocking and encouraging the co-investment by industry partners. World Bee Day is another one of the Wheen Bee Foundation initiatives, and Wheen Bee Foundation is very proud to be the Secretariat for World Bee Day in Australia. We fund an independent web platform that enables people to register for free any events that they have during World Bee Day, which is on the 20th of May. So we've had 2 years of World Bee Day events, and they've been extremely successful with and with growing success. One of our other projects is our Bee Ambassador program. Our Bee Ambassador program is really about connecting industry bee champions from around Australia. So in my role, I'm very fortunate to be able to meet a whole lot of people doing really exciting, innovative things. And I was constantly thinking it'd be great if I could just link people together. And so through the Wheen Bee Foundation and through the support that we're getting with our partners, we've been able to get the Bee Ambassador program up and running. And so we've got about 30 bee ambassadors across Australia in about 5 or 6 different states. And we'll be growing that program, continuing to link these bee champions, provide networking support. And one of the really interesting things that came out of the last Bee Ambassador program was Australian Pollinator Week. So one of our bee ambassadors, Megan Halcroft, had initiated Australian Pollinator Week some years ago, and she'd really just was reaching out and seeing what support we could provide. So Wheen Bee Foundation was in a really good position to be able to work with Megan to be able to, and Wheen Bee Foundation has become Secretariat for Australian Pollinator Week, and we've provided some funding for brand upgrade. We've funded the development of an online platform website that then allows people to find different events that are happening during Australian Pollinator Week, and people can celebrate both independently but also together through this site, and where they can list all of their events or go and find events that are happening. We're only a few weeks away from Australian Pollinator Week, and at this point I'd very much like to flag the fact that there's going to be a lot happening. Go to the site and have a look. You may have events you want to run that you want to advertise for free, you can do that. You may be looking for something to do, you can do that. And we've got certainly about 8 or 10 webinars. So Wheen Bee Foundation will be running the Wheen Bee Foundation webinar series through that week. And so each of the projects that we're talking about will be providing a lot more information. So if I talk about anything in this presentation that you think, gee, I'd like to know more, then go to the Australian Pollinator Week website or Wheen Bee Foundation website. You should be able to find out a lot more information. In about 2018, we launched our Bee Double. So this is very much about helping to raise community awareness about the importance of bees for food security. So this Bee Double goes up and down the east coast of Australia, 7 days a week. It's on the road, going to farms, picking up bee pollinated food crops and delivering them to wholesale markets. So it's really spreading the message of how important our bees are for food security. As part of our projects this year, one of the things we did was to collaborate with Rotarians for Bees and Rotary Club of Canterbury on this Waggle Dance Challenge. What was initially going to be a live event, because of COVID-19, we had to work very quickly to change it. And so it became an online Waggle Dance Challenge. And I'm really delighted to say that that's been a very successful initiative. It's very much about raising awareness and helping people to understand the importance of bees, but whilst having some fun. So it's targeting schools, it's targeting community groups, and it's really about education through having fun. And so I'll just share with you the results of our online the first stage of our online Waggle Dance Challenge, which received about a few hundred video uploads around World Bee Day. We're continuing this particular program, and we're aiming to have 20,000 video uploads from around the world, sharing with people all around the world our enjoyment and love for bees, and also providing some education around that. So here's a little piece of the compilation to share with you. So that's our compilation video. A copy of that is available on our website and on the Wheen Bee Foundation website. But also you can download from there, you can access the instructional video. So if you're looking for a fun activity to run with local school groups, you can go there, and I'd highly encourage you to use that and get involved with the Global Waggle Dance Challenge. It's COVID-19 safe to run. You can do it from the safety of your own home and gardens. And everyone who participated just said how much fun they had doing it. So thank you very much to our industry partners, Rotary Club of Canterbury and Rotarians for Bees, for allowing us to join on that initiative. Of course, 2019-20, has had some major impact, and the devastating bushfires were a major issue. So what Wheen Bee Foundation did when the bushfires first happened, we didn't feel that there was a role for us, because our charitable status, means it requires us to fund research and those types of activities, research conservation type activities. We're not in the business of funding emergency response. But when the bushfire activity went on over some period of time, it became very apparent that we were being contacted by people from overseas wanting to provide us with some funds. And so we've been able to, we had a strategic meeting, and we put together a plan, and we launched a strategic bushfire rebuild and recovery fund. So I'm very pleased to say that as a result of that, we've raised some significant funds, and during Australian Pollinator Week, we will be launching our 5 Bees program, which is building better beekeeping businesses after bushfire. This program is very much a long-term recovery program. It's not about emergency response, and it's really about working with commercial beekeepers to support them and support their businesses. So we'll be telling you a lot more about that program during Australian Pollinator Week. We've received a number of funds through the Wheen Bee Foundation website from all sorts of people, and then we've also had some significant donations from these foundations and organisations listed on the slide. So, you know, we can't support these programs without the support of a lot of our sponsors, donors, benefactors, and so I acknowledge and thank all of them. So I would encourage commercial beekeepers to register for our webinar and see how you might be involved and how this program might be able to benefit you and your businesses. One of the other things that we did as a bushfire response is we funded a green carpenter bee conservation project on Kangaroo Island. We launched a native bee research fund during Australian Pollinator Week last year. And that fund, this was a project that was launched as our hero project for that year. We've been able to, since launching that native bee fund, we've raised over $50,000 specifically for the Green Carpenter Bee project, and also some other funds for native bee general conservation. So we're really proud of that. And again, you know, Seacology is an American charity that was really concerned about the bushfires and contacted us and got behind, and then ran a crowdfunding campaign with all the funds coming to Wheen Bee Foundation for this project. So I think that shows some of the power of being a charity, a registered charity in this space, that we really have the capacity to bring new funds for the industry and for bees in general in Australia. One of the other projects we're going to be launching during Australian Pollinator Week is our Discover Bees project. And the Discover Bees project is a campaign to accelerate the discovery and documentation of Australia's native bees. So currently we estimate there's probably around 2,500 bees in Australia. Only about 1,650 of those are named and known. And the bushfire was a great example of where we're losing species. We actually don't know what we've got. So it's very hard to monitor the impact of things like climate change, habitat loss, bushfires. Very hard to measure and evaluate what we're losing when we don't know what we've got to start with. So Wheen Bee Foundation is getting behind this project, which is to be able to name all remaining bee species in a 6-year period. And we see this as a really important project. So we'll be talking a bit more about that during Australian Pollinator Week. So if you have an interest in that, please jump on board the webinar. I'm also really, really delighted to announce today, for the very first time, that Wheen Bee Foundation has set up a partnership with Pollinator Partnership in America, our sister charity organisation. And with the support of some funding we've received from the Hazel and Arthur Bruce Bequest and Flow, we've established a licensing agreement with Pollinator Partnership. We have the rights to bee-friendly farming in Australia. And so Wheen Bee Foundation will be launching bee-friendly farming program in Australia over the coming few months. So I'm really thrilled about that, because it really fits in so nicely with our Powerful Pollinators project, which talks about what to plant, and then bee-friendly farming is really about the implementation phase of farmers committing to bee-friendly farming practices, which of course makes the environment better for all of our bees. So one of the final projects I wanted to mention was our Business Buddies project. So I said that without funds coming in, we can't help and support and run these projects. So our Business Buddies project is a cause marketing program that works in partnership with businesses. And businesses make a regular contribution to the Wheen Bee Foundation. That contribution is generally linked to a share of their business or product sales. So, for example, one example is Indian Harper. We have a jewellery company and they sell jewellery online, and they've got some bee jewellery, and part of the proceeds of each of those are committed to come to the Wheen Bee Foundation. So we have a number of business buddies online that will be growing, and we would be really delighted to partner with anyone who's interested in being recognised by Wheen Bee Foundation for your contributions as a business buddy, and also who wants to talk to your customers and clients and let them know that you're doing a charitable thing and making contributions to our bee cause. So how you can benefit? Well, obviously these programs all vary very differently, but there's programs in there that are really about improving your business viability and performance. So Plan B is one of those projects. Our 5 Bs project is very much about improved business viability and performance. So that might be of use to you. Improving floral resource access and availability and making farms safer. So our Powerful Pollinators project, our Bee Friendly Farming project, they're both about delivering on those benefits. Providing promotional support, fun and educational activities and event ideas. Well, our Waggle Dance Challenge is one of those. World Bee Day on the 20th of May, or Australian Pollinator Week in the 2nd full week in November, are all ways in which we can support you, your clubs, your communities with fun and educational activities to do. If it's networking and training opportunities for bee champions or volunteers, as a club, if you're wanting to reward your volunteers that are doing a lot for your club, then our Bee Ambassador program is a really worthwhile activity to get involved with, program to get involved with. And if you're interested in improved biodiversity and ecosystem health, then the Discover Bees program is certainly doing that, but as is the Powerful Pollinators, as is the Bee Friendly Farming. So there's certainly some crossover, but depending on what it is you're looking for, I think we've got a project in there that can help you. To find out more information, please come to our webinars during Australian Pollinator Week. Have a look on the Wheen Bee Foundation website. We'd be really thrilled to have you subscribe to our e-newsletter, and if you're in a position to become a business buddy, then we would love to partner with you on that. Thanks very much for listening. I hope that's been informative, and I hope it's really given you an idea of just how much Wheen Bee Foundation really is doing to support bees and beekeepers in Australia. Thanks, everybody.